All right, let's switch over to the homework. Okay? So, we want to find this area of the shaded region. What is different about this region? What makes this region more complicated? What would need to be done to find the area of this region? Brace that, discuss this with your neighbors. Go.
Oh, you know what? Because the intervals aren't equal.
Oh, don't give me there's no intersection points. I could give you the intersecting points. Is that one? Oh, but yeah, there's a lot of them. 2, 3, and 6. So, if we thought about our rectangle that has a top and a bottom, we realize the top and bottom could be different depending on where you are located. Which means, and this is important, it's a new thing, instead of just one rectangle and just thinking about like between two things, it's important to think about sums as starting from the left and going to the right. If I started left and started traveling right, I would need one integral for these black rectangles. And again, I'm summing up the areas of these rectangles, the height, which are a y top minus a y bottom. The y equals top is y equals x squared. The y bottom is y equals 1. I'm summing them up from 1 to 2. Okay, good. That's just this portion. But then I need to switch to my red rectangle. My red rectangle, and I need a dx because that's the height times the width. Width being a very small x distance. Then my red rectangle, I'm going from 2 to 3, but the top minus the bottom is y equals 4 minus y equals 1. And then I need my blue rectangle. From 3 to 6, this 3 is not located in a spot based on the graph. From 3 to 6, where the top is 7 minus x, and the bottom is 1. So 3 different tops. Go ahead and plug this into your calculator. And even just plugging that into your calculator, it's going to take a long time. But imagine if I asked you to do this without a calculator. Whew! That'd be so much arithmetic. Oh my goodness. I can always count on Morelli for good comments. That's what the calculator does. Unbelievable. What do we get? 8.83333. Cool. Cool. All right. What about this one? Now, I don't have to. You could find them. The intersections here are at x equals 1, and the intersection here is at x equals 5. Set up integral or integrals to find this area. What's different about this one? How many integrals do you need here? What would be in the integrals? To discuss with your neighbors, go. Write them down. Zero to 115 is correct. So this is why the rectangle is so important, guys. Drawing of the rectangle, and maybe instead of just putting it willy-nilly anywhere, we're going to start drawing them from left to right, or think about it using your pencil. Like, what is the top minus bottom? Well, from 0 to 1, y equals top is y equals 10. Y equals 2 is the bottom. So from 0 to 1, the height of these rectangles is y equals 10 minus y equals 2 with dx. And then from 1 to 5, the y equals top minus the y equals bottom is y equals 10 over x minus 2. 16.09 or something like that? Cool. All right, hold on to that number. What about this one? Again, you don't need it. You can find it. I'm giving it to you because I just want to get to the heart of the matter here. Get this area. Go. What happens if there's no bottom? Y equals 0. Good. Very good. So this is important, like understanding, like, if there's no bottom, well, there is. It's y equals 0. Okay? And again, man, even typing these into our calculator, it takes a decent amount of time because there's multiple intervals. Well, what if I told you that you can get this answer 8.8333, this answer, what was it, 16.09, and this answer 1.16, you could get those answers by using just one integral. Yeah, I know.
Is it an integral of integral?
No, that's multivariable calculus. Okay? What we need to do, and this freaks students out because it's different, change our perspective. Change our perspective. Some of you are already there. Because depending on our situation, instead of using multiple vertical rectangles, we could use horizontal rectangles. And we would be able to get an easier sum of horizontal rectangles. Instead of using 2, I'd only need 1. Here, instead of having to use 1, 2, 3 sets of vertical rectangles, I could use just 1 set of horizontal rectangles. How are we going to do that? What does that look like? Well, erase these stuff, erase this stuff, erase this stuff, and let's just, talk about the vertical rectangles we've been using. Okay? Start with our vertical rectangle. Draw a rectangle. This is in the notes. Draw a rectangle. Understand this is a skinny rectangle. We have a height that is a y distance. Okay? We have a width that is a very small x distance. dx stands for a small x distance. Got it? To find an area, we are going to accumulate the areas of those rectangles. Now, to get this height, this y distance, we take the y equals on the top and the y equals at the bottom, and we subtract them. This is where the y top minus the y bottom comes from. And I'm just going to put that again. Or maybe I'll just say height is y distance. I like that better. The width, very, very small x distance. We sum them from a left to a right to cover all of the area. However, these are x coordinates, an x left, an x right, right? This x coordinate here, this x coordinate here. Let's shift our perspective. Now, we're not going to shift the graph. Instead, we are just going to use, my friend, the horizontal rectangle. Okay? All right. Now, what are the characteristics? Well, the width is now this length. The height is this length. One of the two is easily labeled because it's very small. Which characteristic of this rectangle is small? The height. And how would we label it? It's a very small y distance. Very good. If you understand that, you are paying attention. Now, what about this width? What type of distance is this width? It's a horizontal or an x distance. Okay. So we are going to sum up these widths times these heights. Height dy. How do I get an x distance? The x coordinate, the x equals on the right minus the x equals on the left. Here, if this is 4 minus 1, oh yeah, this width is 3. So my x distance can be found by taking my x equals on the right and subtracting my x equals on the left. But we're missing one part. What goes here and what goes here? The y values, because it makes sense to sum these up from a bottom to a top or vertically. Now we do a bottom to a top versus a top to a bottom because we want to be going in a positive y direction so that my dy, my heights are positive. So we will go from a bottom to a top, but these bottoms and these tops are y coordinates. Okay, let's see if we understand things. Let's go back to our homework. And let's shift our perspective. Boom. Okay. Here is my rectangle with a width and a height. The width being an x distance. The height being a small change in y. My width being a right x minus a left x. Okay, well, the right equation is this line, so I guess it's the 7 minus x that goes first. The left equation is the curve, so I guess it's the x squared that goes second. Oh, wait. Well, let's just try this. What would these numbers be here? All right, good. A bottom to a top, that's a good understanding. So it's not 1 and 6. We are summing these horizontal things up from a bottom to a top. So 1 and 4. Now, if I type this into my calculator, I expect to get 8.8333. So I plug in math 9, I go 1 to 4, and I got my right, which is the 7 minus x, minus my left, which is the x squared. It's dy, but whatever, I'm just going to use dx, and I get that. Oh, that's not right. And this is, a lot of you guys have already figured this out, which is great. This is because this is wrong, what's inside here. These are y equals distances. This is y equals 7 minus x. This is y equals x squared. These are y distances that you're subtracting. This is the top minus the bottom. What you need is x equals distances. So we get an x to the right and an x to the left. Which means, what do we have to do? Take your equations and solve them from x. Now, a lot of you don't like doing this. And it's like, oh, why do I have to? This is so, like, oh, this is intimidating. It's really not that bad. Some of them it's easy to do. Add x, subtract y, x equals 7 minus y. So this changes to 7 minus y. Oh, it's pretty much the same exact thing. But this does not change to x equals y squared. You have to square root both sides to solve for x. This equation turns into x equals root y. Let's plug in this integral into our calculator. Oh, how do you type y's in? Good question. You could either decide to understand that the variables are the same, so use x's, or it's not, you're good. And boom, we get our correct answer. Or if you don't feel comfortable doing it, you can alpha y to your heart's content. 7 minus alpha y minus. Oh yeah. Got a alpha y. So yeah, maybe just use x's, right? Okay. Let's see if we can change our perspective for the third one. Yeah, let's do the third one. Then we'll come back to the second one. So we realize there's one difference is that we need to solve for x. So we have x equals right and x equals left. Sometimes it's easy to solve for, and it ends up being the same thing. Sometimes it's different. Here, I got x equals y squared. Here, x equals 2 minus 1. Now, you need to get 1.16 when you plug stuff into your calculator. Again, it's all about the setup right now. Let's see if we can figure out. What's the height? What do you mean the height? The height is dy. Whoa. Horizontal. Draw it. See it. Width. Height. Okay, good. So you know you have dy for your height. You know your width is an x right minus an x left. The x on the right is x equals 2 minus y. The x on the left is x equals y squared. And obviously we go from 0 to 2. 0 to 2, right? Because that's all the values we've always used. No. This is why drawing and visualizing is so important. You are summing these up from a bottom to a top, which means you need a y equals 0, not an x equals 0, to a y equals, well, if I plug in 1 into both these equations, I get 1. This is 1. What? Because you're summing up the horizontal things. And it makes sense to sum up these horizontal things vertically. From a y coordinate to a y coordinate. 0 to this intersection, the y coordinate of the intersection.
So because it intersects at x, you flip that to become the y.
No, it's because when I plug in 1 for the x's, I get 1 for both of these.
But it will always be like, if that's the case, it'll be where it intersects, that's where you plug it and you get 1.
Yeah. Let's do this one. Digit. What did you get? Because I get a little bit confused here. I've always been right minus left, but I don't see the left here. Oh, the left is x equals 0. That's a vertical line, that's the y-axis. So I do this equation solved for x, it happens to be the same, won't always be, is the right minus the left being x equals 0. dy, do I go from 1 to 5? No. We just talked about this. From 2 to 10. And you get 16.09, right? Is that nice? Okay, great. Let's see if you really understand. Let's go back to our notes. I know. Let's go to this guy.
He was taking.
Excuse you. Now, this intersection, guys, you can find. It's when the two equations equal each other. It's when x equals 9. And that's when y equals 6. Okay, let's do the way we learned last class. Let's go vertical first. Same question on the homework. If you want to do the question on the homework, then it'll be fine.
I'm going to do
Okay, go. Yeah, but I want you to do it two differently. Draw the rectangle, guys. Draw the rectangle. And with our vertical rectangles, you may use your calculator. It's all about the setup. That's the most important part. We have to learn how to set up, and then getting the correct answer is secondary importance, because if you don't know how to set up, you'll never get the correct answer. Using vertical rectangles, you get 0 to 9, 6 minus 2 root x. Cool? Okay. That should be like known. That should be fine. Now, change your perspective and go horizontally. I don't want you to like shift your paper, but if it helps, do it. Okay? We have widths, which are x distances. It's an x right minus an x left. We have height, that are very small y.
Well,
Because it's right minus left.
um,
Whatever, we should get it. We should get the same thing. We should get the same thing. Go, figure it out. Yes. So this is showing you the calculator. No, uses a Riemann sum, and sometimes the Riemann sum that it does produces such an accurate answer that it rounds to the exact. But sometimes the Riemann sum it uses is a little bit off. This is an example of your calculator being a little bit off this way. But if we plug in the alternate way, we'll get an exact answer of 18. Okay? What is your other integral that you wrote down? Write it down. Write it down. Everybody write it down. Because I know we all got this, but did we get the purple rectangle? The right is the curve. The curve is the y equals 2 root x. You need to take y equals 2 root x and figure out the x distances. The x equals distances. Divide by 2, square. You may either keep it as x equals, in parentheses, y over 2 squared, or y squared over 4. 18 on the dot. Ah. The little curve is on the right. Yeah. So we should have this in our integral. Y squared over 4 minus 0 is a right minus a left. dy is the height. Y equals 0 to y equals 6. Bottom to a top. Right minus left gives you a positive x distance. Right minus left. I cut them off. Okay? This equals this, which equals 18. Now, you're probably thinking, well, Mr. Messner, for this question, it's different than the other question. Why? Because I could use one integral either way. Like, this is one integral, that's one integral. So it's like, why do I care about horizontal rectangle? You know, why can't I just stick with vertical? Well, when we get to next lesson, you are required to use horizontal things that are going to be spun to create three-dimensional objects that we will find the volumes of. Okay? But that's next lesson. This lesson, you will be required to split regions in half. Okay, sure, Mr. Messner, that's fine. I've done that already. But split it in half horizontally. Find y equals k, not x equals k. For the question we just did. For the question we just did. That's not on the homework, so this is in your notes. So this is practice. Now, if you think about setting this up vertically, it is a much more complicated problem because it involves using like the intersection with y equals k, which you don't even know, and y equals 2 root x. You would have to have a top minus bottom of k minus this. You don't know that. So the way to do this is with your new friend, the horizontal rectangle. This is a question that you could do without a calculator. Let's see. The overall area we already found was 18. So half the area is 9. This area here is 9. What's my setup? Tell your neighbors. And some of you are already working on this. Some of you are like, I don't know where to start. Get your setup. I would probably simplify that before I took the anti-drag. Come on, switch your perspective. Where is it? Yeah, you're good. Yeah.
So what?
That's your answer. I think it's bigger than that, though.
No, I don't think it's big.
Ooh, then times 2? Oof. All right. All right. Ready? Summing up my purple rectangle from 0 to the y coordinate of k. Y equals 0 to y equals k. That's a bottom to a top. Of my right minus my left. My right is y squared over 4. Some of you have kept it as y over 2 squared. It is easier to deal with if it's y squared over 4 when we're taking antiderivatives in this solve. Minus the left. The left is x equals 0. X equals the right. X equals the left. Times the height dy must equal half of my area. Ready? We take the antiderivative. I got y cubed over 12. I'll find the change in that between 0 and k, set it equal to 9. I get k cubed over 12 minus 0 equals 9. 9 times 12 is 108. You might get the same answer. You just did it in a different order. The answer is the cubed root of 108. Nope. It's not going to be 6 because 6 is this line. Y equals 6 is this line. You're obviously not splitting it in half if it's at 6. Now, did you split your area in half and use 9?
I did. I think what I did was okay. I think it comes from I did y over 2 squared. You did y squared work. So I think I must have just had an error in my answer.
So yes, if you use y over 2 squared, which I saw other people do, your antiderivative would be y cubed times a third, but then times a 2.
I forgot. Wait.
No, times a half.
No, 1/4 times y squared.
Oh, hold on.
1/4 would be the constant. So then your derivative would be 1/12.
No, it would be times a 2. So then if you cube this, you get y cubed over 8, but then times the 3 in the bottom, which is 24, but then you need a 2 over here. So, like I said, simplify before taking the antiderivative. Yes.
Yeah. So like 1/4 is a constant times y squared, and then y cubed, and then you have to do
Is it the same as the cubed root of it? Okay, before we leave, this is probably in the homework, honestly. Let's look at part C. Now, read the question carefully. Watch what it asks. Write, but do not solve an equation involving one or more integrals. So, ready? We are splitting this in half. Y equals k. We would have to use our calculator to find this intersection. Now, we have not done this yet, but when you find intersections, you can store the y coordinate. Log x, 5 minus x. I'll do this fairly quickly. Second calc, intersect, boom, boom, boom. Y coordinates can be stored. Alpha Y helps sometimes. Now let's just write this number down, 1.306. This is a calculator problem. Ready? Without finding the area, I can answer this question. Now I have to solve these equations for x. Hold on. How do you solve y equals log x for x? E to the power. Good. Okay, ready? An integral from 0 to k of my right minus my left, 5 minus y minus e to the y, will equal half of my area, sure, but I don't have the area. Okay, that's fine. K to 1.306, the top half. This is like a quick way to get around like having to find the area. Like they just want an equation, here's my equation. They didn't even ask you to solve it, okay? All right, I hope we embrace the shifting of perspective because it's very, very necessary moving forward in this unit. Thank you. That's the answer.